Okay. Okay.
Okay.
Hello everyone. I'm Sumaila. I'm currently a research student at the University of Alberta, and I'm here to just give an overview of carbon dioxide removal and carbon capture storage. So like these technologies that we've probably heard and also heard some aspect about in this couple of years as we are all trying to work towards achieving net zero in the coming future. So in today, just a brief overview. I'm just going to just talk about s- an overview of some of the technologies that are currently existing and that are being sort of in motion or currently in motion in projects at the moment. So I'll just start. So the first question we would like to ask ourselves is, why do we have to address CO2 emissions? And I think basically the answer is very clear for most of us. You realize that as global warming temperature keeps rising, the environment and the ecosystem keeps having certain challenges, and that's adversely is going to affect so many aspects of our life, yeah, in this globe. So it's kind of a challenge because it's not just an environmental challenge. It's going to affect all spheres of life, be it the ecosystem, even in terms of like finances, and there's so many that's going to get affected through these climate challenges. There is the need to obviously reduce emissions and remove legacy CO2. As you can see, as you can see on my the chart on my right, this is a classic Killing curve style graph showing atmospheric CO2 concentrations over past years.
Uh,
And you can see,
Sumila, I'm very sorry to interrupt. I think you need to share the screen of your current display. So what we can see is just the PowerPoint, you know?
oh,
Are you in the entire screen of the PowerPoint? If so, then you need to share that entire screen. If not, I suggest you to just, move the slides up and down so that we can see what's going on.
oh, okay, yes,
Yeah, yeah.
okay,
Yeah, very sorry
I
for that.
think, okay, no problem. So let me, should I start or should I continue?
Yeah, yeah, you can
So let me
continue.
reset this, let me
Yeah.
reshare the screen then. Can you see the screen?
Yeah, I can see the screen. Yeah, and then you can.
Yes.
Okay, that's good.
Yeah, I can. Yeah.
Thank you. Thank you for alerting me. So I was saying why I was just on this particular slide and I was saying why is this there why is there a need to address CO2 emissions? Um and you can see from the right of my graph from the Killing curve style, that's where I got this figure from, that there have constantly been an increase of CO2 levels across the past years. And as you can see, it's constantly been there's been a constant increase across the years, and this can have a very devastating impact, not only not in environmental wise, but also in terms of ecosystem and other aspect of like human lives. So it's very important that as scientists and stakeholders try to sort of address this issue and try and find all sort of mitigations and technologies and all sort of resources to help fight this challenge and sort of keep a very good balance of emissions and absorption of CO2 between the atmosphere and the environment. So there's this is very pressing issue, as you can see, very pressing issue, and this could have very high impact to human life. So today I would like to focus about two. two terminologies. The first one is carbon dioxide removal, which I've said is CDR in short, and carbon capture storage. So, what is CDR? The definition of CDR involves extracting CO2 from the atmosphere directly and storing it for long-term purposes. In terms of storing it, it can be you either try to inject it in the subsurface, or you try to make byproduct of the CO2, maybe let's say in cement industries. So CO2 as kind of part of their making, making stocks to produce cement and other products. So that those are the those are that so that's what CDR means. So the reason why I'm trying to get a bit of differentiation is kind of CDR and CCS have a kind of similarities, at the same time they are a bit different. So some people sometimes use the terms interchangeably, and one may get easily confused exactly what one is talking about. So in this presentation, we'll try and get some of these um, main differentiation between these two terms. So what are some of the examples of CDR? We probably know that afforestation or reforestation, which is like the planting of trees or the replanting of trees when they are being cut down from the forest areas or from reserves across the globe. And this is mostly done because we all know that plants sort of absorb CO2 to certain extent, and helps sort of reduce CO2 emissions in the atmosphere. Direct air capture, on the other hand, is kind of relatively, I would say, a new technology being developed in the recent past, that sort of capture CO2 from the atmosphere directly. We'll go a bit detailed into that. Bioenergy, popularly known as BECS,
Tudo. Me
with
phone đã
carbon
được rồi.
capture storage,
Hai
is
phải xin
trying
đã
to
làm
sort
phiền
of
gì. Phone đã này về cái nào phải lại một phải. Lại một
use
phải. Mà
biomass
machine tudo computer
to
wifi
produce
phone thì nào
energy
phải.
through
Lại
biomass,
cho nó cụ về thà lại.
and the
Cho nó
CO2
cứ
that has
còn
been
lại còn lại.
produced by that is captured and stored
Ừ.
within
Mà cuối
or
nào
beneath the
có phải đi đá đâu
subsurface,
con.
or utilized in an industry for a byproduct or a product. Biochar is also an example of a CDR where we sort of look at um, heating organic masses or pyrolysis. It involve a process called pyrolysis, which is high temperature, and it's sort of kind of mostly done with little or no oxygen at all of organic masses. And the idea behind biochar is that since we know that some plants or some organic matter may contain CO2, when we sort of burn them under this high temperature, which I did mention is pyrolysis, with or without oxygen, we sort of turn them into biochar through that process, and this process, through that, we sort of store them in soils for soil remediation purposes. Ocean alkalinity, um also kind of a mineralization process in the ocean we see. So we try to in this process, mainly we try to look at how we can increase the alkalinity in the oceans. And why do we do that? Because the ocean is also like a carbon sink. And what I mean by that is it sort of captures CO2 from the atmosphere naturally, even without human intervention. However, it depends on certain factors, and that also depends on how alkaline, or the alkalinity of the ocean. So trying to increase the alkalinity in the ocean is also a way of sort of trying to boost the process of CO2 capture. And when this is done, mostly the products we get from this mineralization process, CO2 being captured, is forming carbonate or bicarbonate precipitations in the ocean, which is a form of a solid form, mostly for turning CO2 into solid states. So what is CCS? Probably this one of this the most common among all of them, like we've been hearing much more. So CCS is basically carbon capture and storage. So we capture CO2 at point sources like power plants or heavy industrial emissions area and store them beneath the underground. The key steps we look at in this is mostly we capture, we transport and store. So these are the three main key process steps we sort of look into in when it comes to CCS. It may just be so simply like three-step process. However, it's more involving than just a three-step process, because before we sort of um do any evaluation or anything regarding CCS projects, we have to sort of evaluate the subsurface and see the suitability of it, whether it can really we can store CO2 with it, because there are certain factors we need to consider. Since today is an overview, I wouldn't go so technical about certain aspects, but I'll try to highlight some key aspects needed or some of like the CCS storage, you know, um, projects or subsurface injections that are currently being done or that have been done in the past. So in you can see on my right here an image, and just giving a brief illustration of how this image works. We have a cement manufacturing plant, which is one of some of the industries that emits, let's say, probably high CO2 into the atmosphere, as you can see by the illustration. It's weird to see that this nice image from Martin Camp has also some, trees around surrounding just close to the plant. So the idea is that even let's assume that they weren't performing CCS projects in this particular area, the, the natural instinct, the natural uptake of CO2 from the atmosphere by these these plants are also going to support, like I did mention, that reforestation and forestation as part of the CDR tech. So you can see that sometimes it's not necessary that you find only one kind of CDR technology in a particular um, carbon capture space, or tech or project being performed. There may be one or two combination, or it just could be just one CDR tech that's being performed. So you can see that. Now let's go a bit deeper. So you can see there's pipelines connected to the cement manufacturing plants, and within the subsurface, um, geologists may have a better understanding of how variable or how what term am I looking for, inconsistent the subsurface can be. However, you realize that within a subsurface there are various rock units, sedimentary formation, different kind of varying formations that you need to look into. And mostly this is the idea of carbon capture storage comes from years of experience in the oil and gas industries, who've been sort of extracting oil and gas within the subsurface from different kind of formation. So within the subsurface, we try to look at the cap rock, which is like the seal, and we look at the reservoir, which is having certain particular characteristics which sort of store. It can store water, it can store oil. Then so these are some of the storage spaces, and so we try to pump the CO2 into some of these storage spaces. But however, there are different storage spaces that's been discovered so far. We can store the CO2 safely, and which is more as a permanent storage and a more environmental friendly. So you can see we can store CO2 in coal beds. That's one way. And we can also store them in saline aquifer. That's also another way. Then we can store them in depleted oil and gas reservoirs. So these depleted oil and gas reservoirs are sort of reservoirs that are no more, being sort of extracted for oil and gas, and they have some kind of storage still left, and we can, of course, in practical there will be some aspects, a little bit of remaining oil and gas or oils left, but not so economical, so to speak. So there's that possibility to utilize those depleted oil and gas reservoirs for CO2 storage, since they have all the ticks that sort of favors that, because there'll be a cap rock or a seal which serve as a cover above the reservoir to prevent them from you know escaping towards the atmosphere. You also have CO2 storage in salt beds. That's also another aspect. So these are some of the key components in terms of carbon capture storages. Within the subsurface, we can store our CO2. And some of these formations are, like I just mentioned, a geologist or geologist knows that the formations within a subsurface are very variable. And it's so nice that you can store the CO2 in such a way that, hoping that it will react with certain minerals within a subsurface to form solids. And mostly when we are looking at such formations, we look at formations that are of like ultramafic to mafic minerals, sort of compositions. They sort of favor reactions with CO2 because of their divalent metal cations, which is mostly magnesium 2 plus or calcium 2 plus ions. And this can enhance, forming solid states with CO2 within this subsurface, which is a bit much more secured than if it is left in a solid to liquid um, aqueous state. So I would like to move on. So what are some of the differences? We've talked about definition of CDR, which I mentioned is carbon dioxide removal versus carbon capture storage. What are some of the differences? So I've done a bit summary here. So these are the features we can sort of point on to look at the difference between CDR and CCS, where the source of CO2 is mostly from the atmosphere when it comes to CDR technologies, and carbon capture storage is mostly from industrial point sources. For the goal in CDR is to always get negative emissions. However, the goal of CCS is to reduce emissions as much as possible. In terms of scale, it's kind of distributed, and it's fairly performing some of these CDR technology. Let's say, for instance, direct air capture. In terms of geolocation and like where to actually build some of these techs, is kind of a bit not rocket science. You can decide to probably I'm not an expert in direct air capture, but I believe you can just look at a favorable, when all your checkboxes are being ticked, whether government licenses and everything is being established, you can look at a favorable location and try and build this technology there to capture CO2, since you're trying to capture CO2 directly from the atmosphere. But when it comes to CCS, it sort of has to really depend on the subsurface you are going to sort of store the CO2. So maybe you can even find, let's say, a very conducive subsurface in within a place where people are actually living, like a metropolis, or people's a neighborhood. However, which is very good to store CO2, but unfortunately, environmental regulations and maybe government policies and safety requirements may not allow that. So CCS is kind of geolocated, so some sort of like it depends on the location of the of the geology and how favorable it is within the surrounding communities. And this will have to deal with a lot of um government policies, environmental requirements needed to set up such facilities, because this is related to something that could have we don't always wish for that, but just in case maybe s- the worst case scenario happens, people are still safe from CO2 being released, so much CO2 being released at a time from maybe the subsurface to the surface, so that it doesn't affect people's the surroundings or the plants around. So an example is direct air capture and enhanced weathering in CDR text. So enhanced weathering is kind of trying to you are trying to sort of we know that mineralization CO2 can sort of combine with certain key minerals, like I did mention, preferably ultramafic to mafic sort of mineral contents or rock contents. So in order to sort of stimulate that mineralization or enhance that, the faster combination of such rock units or such minerals with CO2, we adopt concepts like enhanced weathering, where sometimes we try to sort of, let's say, grind a particular rock unit we know contains certain minerals that can, when we expose that mineral to the atmosphere, it can quickly capture CO2 and form solid rocks or solid states. So an example of a CCS at cement plants, as I just shown in the previous slide. So that's also an example. So these are some of the key not an exhaustive list, but some of the key differences between CDR and CCS. So technologies in action in carbon capture storage, or CCS, we have a post combustion capture. The method captures CO2 from exhaust gas of power plants and other industrial sources after combusting fossil fuels. It usually uses amines or solvents to absorb CO2 from the flue gas. An example I can give here is the Boundary Dam CCS project in Canada, which is one of the first large-scale facilities to capture CO2 from a coal-fired power plant. The next technology to look at, which is in action in terms of CCS, is pre-combustion capture. So in this process, CO2 is removed before combustion happens. Fossil fuels are converted into hydrogen and CO2, and then CO2 is then captured. This is primarily mostly in gasification processes. An example I can give of such projects that is currently ongoing is the Petra Nova project in Texas in US, which captures CO2 from a coal gasification plant. The third, the third technologies or the tech technology I would like to look at or like to talk about it, oxy-fuel combustion. And this method sort of burns fossil fuels in pure oxygen instead of air and produces a concentrated stream of CO2 and water. So the CO2 can be easily separated and captured in this process. And a clear example of such project happening is from Clean CO2 project in Europe, and they are kind of exploring this kind of method. So direct air capture, which I've mentioned previously, is also another CCS tech, and um, it's another CDR CCS tech we are looking at, and that one involves sort of chemical removal of CO2 directly from the atmosphere. So they have these large fans that is sort of it blows and sort of traps CO2 as these fans are working through filters, and they go through a whole kind of chemical process to capture the CO2. And we have sort of a solid and a liquid phase of that, two different parts of DAC, which is then compressed, then is finally stored underground. And of course, we can also sort of, if you decide, for instance, the project, okay, when we capture the CO2, when we process the CO2, we can decide to, like I did mention, send it to a cement plant or some industry to make a product or a byproduct. Aside from storing underground, if that's not a viable option in whatever project that's been discussed at the moment in terms of DAC utilization. An example is Climeworks, which is probably one of the most common projects in Iceland. So the company is sort of the leading, mostly the leading company in DAC with a commercial plant in Iceland. So what they do is they capture CO2 um, using their DAC, tech, and they store them in basaltic formations, and which sort of with time, so because it's having like back again this ultramafic and mafic content rock in it, is able to mineralize with the CO2 in solid states for permanent storage, and they have done a marvelous job, and it's still ongoing project. And I think, if I'm not mistaken, they are doing they are trying to upscale the project, in make it a more upscale the project that they are currently working on in Iceland. So storage, which is like the usual one of, after CO2 is being captured, is stored in the geological formations such as deep saline aquifers or depleted oil and gas, which I did mention. So Sleipner, or Sleipner, if I'm not, hope I'm pronouncing the name rightly, Sleipner in Norway has been storing CO2 under the North Sea since 1996. And this is a very, very good example of deep saline aquifer, the project that is happening in Slavna in Norway. And they've actually been working on um, carbon capture for a very long time, even before Climeworks and other new technologies. These new technologies has been coming up in these recent years. And that's something that you can say is commendable, and it's probably they have one of the, since they have been doing it for so many years, they probably know all the challenges they face, or they have faced, and trying to make the best out of the the projects there. And that's, in my case, is very commendable for them, because during 1996 no one was really thinking about capture, storing, or trying to capture CO2. um People, of course, there were scientists who were trying to bring that idea, and it's been there, but mostly no one was really paying attention to capturing CO2 or trying to reach net zero at those times, because I think those times people were much more focused in you know industrialization and, so, oil and gas and energy aspects, within that industry phase. The project in Norway is very commendable, Slavna project, in my opinion. So, what are some of the technologies? What are some of the technologies in CDR that are in action? So we have, like I did mention, we have afforestation and reforestation, which is the natural capture of CO2 and from the atmosphere by plants, and it's done mostly during photosynthesis. An example of such initiative taking place is the Great Green Wall in Africa, aimed to combat desertification and capture of CO2. The next technology in action to look at probably is soil carbon sequestration, which is you can say is linked to biochar in an aspect, because the text involve agricultural practices to increase the amount of carbon stored in soil. Practices include like no-fill farming, agroforestry, and use of cover crops. And so they've been sort of utilizing regenerative agricultural practices to promote various regions with pilot projects in the US and Europe. And I believe other countries are also focused on this aspect, trying to look at utilizing soil to capture CO2. So we have the next one was, okay, ocean fertilization, which I did mention, like ocean alkalinity. So this involves sort of adding like nutrients to ocean water to encourage the growth of certain plants, to help these plants to increasing their masses in the ocean, sort of help absorb CO2 in greater volumes, so to speak. And when these organisms die, their carbon is sequestered at ocean depths. And there have been some experimental projects like the Loch Ness project in the UK. Through this through this remain controversial due to some environmental concerns. So, like I did mention, some of these projects are probably fairly new, and sometimes when implementing them at first, you may have challenges, environmental concerns from stakeholders. So they have to be cautiously sort of implemented, and at each stage. And this ocean fertilization is probably an example. So bioenergy with carbon capture and storage. This is one of the most interesting technologies out there, which is mostly people termed it as BECS. And what people look at in this technology is actually trying to channel biomass, or producing energy from biomass. Then they capture the CO2 produced through that process and sort of store them underground. An example of that is a Drax station in the UK, which is exploring best technology with plants capture and store CO2 from the biomass operation. So this is what I was saying, that some of these so whilst you are producing sort of I see, in my personal opinion, I see BEX to be some kind of a two-win situation, because the main aim is to produce some kind of, should I use the term, renewable sort of energy. At the same time, in that process, whatever CO2 that's being produced is sort of being captured and stored underground in a very favorable sort of facility. So I see it to be a two-step sort of phase when it comes to the BEX, in my opinion. And like I did mention, it's not that whenever CO2 is being captured that we always rush to store them and beneath the subsurface. There has to be a great detail implementation of. There's also the possibility I did mention in the previous slide, that you can also utilize CO2 in certain industries, as for product making or byproducts making. So all this can be looked at in a single technology, or in conjunction with other technologies. So enhanced weathering, which is like an accelerated way of looking at natural mineral reaction to CO2 from the atmosphere. So it involves sort of spreading silicate minerals such as basalt. And like I did mention, these silicate minerals or basalt, or ultramafic or mafic rocks, contain a particular, composition, which is mostly what divalent metal cations, Mg2 plus, or magnesium 2 plus, or calcium 2 plus, which are very favorable when they are sort of released, when they're in their ion state, very favorable to sort of combine with CO2 and mineralize and form solid states. So in so doing, they form carbonates. So for instance, you have calcium 2 plus reacting with CO2, you are most likely to form calcium carbonate. Magnesium 2 plus reacting with CO2, you are most likely to form magnesium carbonate. And this is a stable form of the CO2 from a gaseous, phase to a more solid phase. And that's a permanent storage avenue of storing CO2 as well. So pilot projects that are underway in places like Hawaii and Scotland. So what other also people look at in enhanced weathering is like they spread some of these favorable like rock unit or these favorable minerals on farmlands, or o- on agricultural lands, and they sort of capture the CO2 based on that. So let's look at the algae based CO2 capture. And the algae can be used to capture CO2 from the atmosphere through photosynthesis. And the algae can it also can be used in biofuels, animal feeds, or other products, potentially leading to a circular economy. An example of such startup is a carbon clean solution, which are researching into algae's potential for carbon removal. So with all these texts, what is now the global context? Let's look at what is currently what international agencies involved or stakeholders involved in CDR technologies or championing CDR technologies or CCS across the globe have said or been saying in the past years. We all are aware that IPCC, the intergovernment um, the IPCC sort of sets like a goal, a climate goal, and net zero goals, and was aiming to achieve net zero emissions by 2050 to limit global temperature rise to 1.5 above pre-industrial levels. As per that was the Paris Agreement some years back, just a couple of years back, not so long, so to speak. To achieve this, they stated the world must not only reduce emission but also remove CO2 from the atmosphere. Hence, we need both carbon dioxide removal, which is CDR technologies I've mentioned in the previous slide, and CCS technologies as well. So we are not only trying to reduce which the emissions, which would have been the case that we would have fully focused on carbon capture storage. However, we have to actually s- achieve a net zero emissions from some of these emission sources, which is mostly we try to utilize some of these hydra technologies, or utilize both hydra and CCS technologies in both cases in certain circumstances. So when we look at the emission gap, with substantial emissions reduction, there will likely be a gap, meaning we will still need to remove significant amount of CO2 from the atmosphere to meet global targets. Direct air capture, like the Oka plant, represent one of the potential ways to fill this gap. And like a lot of people champion direct air capture because it's kind of a technology that's been is going on in some places across the globe, and it's currently, you know, though it may have its disadvantages and advantages, and some of the disadvantage that comes to direct air capture is kind of energy intensive, and the cost is also the cost involved is a bit high. But those are some of the challenges some of these new technologies face, and some of the challenges the brain heads are trying to solve in this new technology in order to sort of propel its advancement in so many places across the globe. So we try to look at, okay, currently what is now happening in terms of the global contents in CO2 capture space, and what are the IPCC or other organizations are looking at. As of early 2025, we realized that there've been a kind of significant concern milestone. So the average global temperature in 2024, which just this past year was approximately 1.55 degrees above pre-industrial levels, making it one of the most warmest year on record. So you can really see that this surpasses the kind of threshold that was set by the Paris Agreement for the first time, and though it gives a very alarming concern to all stakeholders who are involved in trying to solve this or trying to achieve net zero. to sort of propel their technology or their you know innovation in a much more faster pace, because, so to speak, it's kind of looking like we are kind of behind. And truly speaking, that's how it looks like. And the weather, the environment is the environment. It sort of doesn't wait for anyone. It's natural, and the more emissions we keep sending to the atmosphere, which we have to get, there's always have to be a balance in life. So the sort of if you send a particular amount of emissions to the atmosphere, there has to be s- s- the same amount of emission need to sort of be absorbed permanently, or sort of captured, in order to reduce the global warming temperatures that's happening in the world. So there's that balance. So as a student, I used to think that, let's assume that there was no CCS or CDR technologies across the globe. Nature was already naturally absorbing CO2, or should I say high, or CO2 that's been emitted in the atmosphere. So we can take cases like maybe Oman, for some in some part of the regions of Oman, they have favorable ultramafic to mafic rocks that sort of naturally capture CO2 with time. And this has been identified by some talks from one of the papers I like reading a lot was from Professor Killeman. And he's been he has in the past been sort of researching about those rocks, specifically in Oman, and realized that naturally with time they sort of capture CO2, but at a kind of a slower pace. But let's just say that if the emissions hadn't gone beyond a certain threshold or level, as we are experiencing, which is leading to increasing in global warming temperatures at the moment, probably nature would have naturally taken care of these higher emissions that is causing environmental impacts at the moment. However, since, should I say, the damage has already been done, there need to be like some mitigation effect. That's why we always looking at this. We are human beings. We are trying to intervene and looking at some of these CCS and CDR technology to propel, the CO2 capture, the large emissions that is in the CO2 in the atmosphere. We capture them and store them permanently in order to control these global warming temperatures that's rising each year. So, what are some of the opportunities and challenges we may face? This is not an exhaustive list. You can see, it just highlighted some of the key opportunities and challenges in the industry, probably as a whole. And yeah, the opportunities are there. There are climate goals we need to set, like being set by the Paris Agreement by IPCC. And also there are innovations that could be done, like I did mention some of even this technology that's currently being streamed, like direct air capture, BECS. It comes with its own challenges, like cost and high energy utilization. So this, we could look at innovative ways of sort of trying to reduce cost involved, so as to propel investors and stakeholders to invest more in these technologies. And the more we have them, the more we're able to sort of, or the faster approach of capturing CO2 from the atmosphere and helping us reach our goals in the coming years. And of course, for people in the various industries, be it geologists, engineers, or other aspects of life, there are obviously going to be new jobs that are open in every country or jurisdiction. So these are some of the opportunities I see in this industry. What are some of the challenges? Like I've mentioned, high costs, very very high costs in some of these technologies that's been trying to implement, and it's kind of synonymous, or should I say, how do you use the word synonymous? It's sort of similar. It cut across almost all of them. High cost, which is very important. Everything that's highly costly, trying to sort of implement it on a larger scale or implement a lot of such a product, it's always going to be challenging for investors and stakeholders who are going to be involved in it. And the public perception, yeah, it's not everybody sort of who is like, maybe in my case, as I'm a geological student, it's not everyone who's going to be, or who has studied geology and probably or a kind of field related to some of these texts that understand it much better. So in order to sort of make people understand some of these perceptions, like, okay, if you are trying to do a CCS project in your vicinity, you have to come back to, like, come to their terms and sort of, give them some kind of assurance and the reasons why you are trying to do something like that, and why there is that need to do something like such a project. So public perception is very, very important, and also it's very important to always sensitize us, s- sort of educate the public, about the global warming challenges. What I find even most scientists, or even who are even like into, CDR text and or other, or people into environmental concerns, is some people will think that, oh, CO2 emissions is just affecting the temperature increase. However, like I did mention, it's kind of an ecosystem approach sort of thing. So I'll give an example. For instance, if, let's say that, there is, let's say, high temperature, right? And we know that we live in some kind of ecosystem, and whenever there is high temperature or abnormal high temperature in every system, or in any vicinity, obviously it's going to affect the rate of evaporation and all those, and sometimes sea levels and iceberg melting and all those, increasing sea level rise and fall, which relates can even affect places, causing flooding and so many other, natural disasters. So you can just see that just by the increase of high temperatures or alone, it's so many going to affect so many aspects of life. And also sometimes we also don't look at, okay, some of these crops or some of these plants we grow or get food from, some of these sort of produce are sort of used to a particular weather in growing them. So a sudden change of their environment keeps these kind of crops, some, it makes them uncomfortable, so they have to, it takes time for them to adapt to the kind of situation they have been sort of they have been sort of experiencing. So the production level of some of crops, some specific crops may reduce. However, the demand still remains or keep increasing, and this is going to what create some sort of scarcity in terms of food availability to people across the globe, and this is going to what affect what the cost of food, right? Trying to, as when the demand is high, I'm not an economist, but I know at least when a demand is high, and the production is low, it's going to affect cost somehow, and mostly that's how it's going to affect even the average life of every person on this planet. So just what I'm trying to get here is that we solely depend on the environment for our survival as human beings, and anything that impacts it directly or indirectly affects us. So it's very important that we look at, when we are trying to solve climate change challenges or trying to look at these challenges, we see how important they are, that we sort of propel them and sort of encourage these technologies, and these innovative ideas to come on board. And one of the challenges we have in some of these new technologies is scalabilities. That is how vast we can sort of upscale some of these projects. Some of these projects are close in terms of technology readiness level, are very close to like be implemented on a large scale in some of these industries. However, some of them too are still in the exploration stage and research stage to sort of find key concepts, and challenges, and what can be the challenges associated where you're trying to make it large scale, and sometimes funding, which is also one of the key parts in trying to get some of these technologies on a large scale. So there are some of the like brief challenges and opportunities, and in my opinion, I kind of see it's not an exhaustive list. There's so many challenges and opportunities in that space in carbon capture and CDR technologies. So what's the future? So integration with net zero strategies, like I did mention, combining carbon CDR and CCS, or finding innovative sort of strategies that you can combine one technology to another, which could be an efficient um, could efficiently sort of be more efficient than one standalone CDR tech in a particular place. So an integration is very key if we really want to achieve our net zero in the coming years. And emerging innovations, be it AI, mineralization, or any hybrid system, it's also key. And most one of the most important thing is policy and investment needs. So it's sometimes you may have the best CDR or tech available and you can implement it, but because of policies that may be governing a particular piece of land or area or province, it may restrict you from implementing a particular CDR or CCS tech. So that also play kind of a key role in advancing some of these CDR technologies. So those are some of the impacts we can that this can have looking at the future for CDR or CCS techs. So in conclusion, and CDRs and CCS are complementary tools, like I did mention. Yeah, critical for 1.5 degrees Celsius pathway. However, I'll make a caveat here because I just said that last year we recorded 1.55 degrees Celsius. So we've sort of passed that stage now. I don't know whether we can bring that back to 1.5, but on a realistic point of view, it's not looking that point. I don't want to be too pessimistic about that, but of course, rather is how we try to maintain, where the warming potential is, or the temperature, pre-industrial temperature emission is temperature is at the moment. So there's a need for rapid scaling, which have hammered on in the previous slide. There's really a need for rapid scaling if you really want to prevent, worst case scenarios or high environmental impacts consequences happening, which will not look good. It doesn't matter which part of the globe you are. We all share the same environmental space. So whatever affects one particular country or nation or region or tribe, it's certainly going to affect everyone, and it's not going to look good on us. So if there's a need for continuous consensus building, trying to come together to find the best technology, and there's a need to also make some of these technologies rapid, and which has to do with sometimes making policies that favor some of scaling these technologies, and the public and private sectors have to come together as one in terms of solving some of these CDR and CCS technologies. And I think it's very vital because, like some of these CDR technologies and CCS techs are kind of new and they are gaining momentum, rightfully so. But the more we have a joint effort in solving it, the better, and the rapid way of scaling up things in order for us to reach our net zero goals in the coming years, hopefully by 2050, as IPCC stipulated. Okay, so I think that's it for me. I don't know how much time I've made. Oh, almost an hour. I, I didn't plan to do that, but that's it for me. If there's any questions and answers, please, I'm happy. And I'm just gonna throw a disclaimer. I'm not an expert in most of these texts I've mentioned. It's just something I learned as a student, and I'm just sharing the knowledge. And I'm happy to get any second opinion from anyone, and also sort of build on that knowledge and understanding as well. Thank you very much for your time.
Yes, Sumaila, I really listened to your whole talk. It was very high standard, very informative. I know about the CCS, but I didn't really know about the CDR, which you talk in your presentation, which is really informative. So I want to give a floor to Joshkan if he has any questions first. Joshkan, do you have any questions to Sumaila?
Yeah, can you hear me, guys?
Yeah, yeah, we can hear
Wow.
you.
Yes, I can hear you.
Yeah, great. Actually, it's a very informative session from my side also. Thank you again, Sumaila, for the presentation. My question is like, I know you are not expert in that area, but when I look at the technologies, there was written the DAC, I mean direct air capture.
Yes.
Let's say we know like doing the like reforestation or ocean fertilization all will affect the reducing the carbon emission, or we can like capture the carbon from the factories, they will all affect the like reducing the carbon emission, or we can directly eliminate the carbon emissions that we are doing. But as we all know, we are already contaminate the air, and there are lots of the CO2 mixture of the air, and we need to capture the CO2 directly, the tons of carbon from the air, right? It's true.
Yeah.
Like when I see your presentation, there's like two like type of mitigations on this way, which was like air filtering and some using the some chemicals,
Yeah.
like to capturing this directly from the air. My question, or we can challenge ourselves on this side, that do we have any other methods to apply and make it more effective to directly capture the carbons from the air, or do you think that it's an effective way doing like that? Because as we know, if we reduce the emissions, somehow the atmosphere will have a chance to recover itself. Do we need really to do it or not? That's my question actually.
Yeah. So, like I did mention, it's kind of we are in a situation, and in my opinion, that I think we have to do both. We have to try and reduce emissions as much as possible in some of these industries, and also implement direct air capture technologies. So let's say, for instance, I don't want to any sort of high emitting industry across the globe. Let's pick like maybe be the oil and gas or cement manufacturing industries, or whatever industry that's emitting a substantial CO2 emissions. If just from that industry point source we are able to, it's actually, you can't say that, we can't say that the kind of processes some of these industries go in producing their products, eventually it's going to give rise to CO2. And it's not only even in these industries, because even we human beings, there are some things we do that can sort of offset CO2, right? So it's all about like how we try to manage that, which is comes to the first aspect of your question, trying to reduce the emissions. And like some of these texts I've mentioned, for instance, you look at biomass, right? They are trying to, or biomass and energy with carbon capture storage. They are trying to produce an energy. However, the CO2 that's coming from that production line, they don't allow it to go to the atmosphere. Actually try to capture it at the point of the industry, just the industrial level, without releasing it to the atmosphere, and store them and beneath the subsurfaces. So if most industries implement innovative technologies in that sphere, I think that's also a good way. So instead of allowing the CO2 to just leave from their industry, to the atmosphere and expecting maybe dark technology to later on capture it. We are not at a stage for that. I think we've probably gone beyond that level, looking at how eminent or daring the situation is at the moment. So so it's sort of a win-win sort of scenario or case situation that both has to be implemented. As industries try their best level to reduce emissions, carbon dioxide removal techs needs to keep being implemented on larger scales to sort of solve the situation in both
Yeah.
areas.
Yeah, I agree with you. Thank you very much. I understand, like right now, the humans, I mean, as a world, we do not have like capability of reducing the carbon emission to zero right now. It's not possible. I know, I understand. So it's always necessary to initiate the new technologies. I think DAC in this way can be helpful. Yeah, yeah. Thank you
Yeah,
very
yeah,
much for
yeah,
comprehensive answer.
yeah. Thank you for your question. Yeah.
Yeah. So Sumila, if you allow me, I prepare you a few questions. Uh, just a
Okay.
couple from myself, something that I feel curious about, and some couple questions that I think maybe people who want to watch this video again may want to know. Okay. So,
Okay.
you and I, we spend time in the master degree. We mostly look at the subsurface aspect of, oil and gas extraction, let it be sustainable projects and things like that. So I just want to
Yeah.
know your opinion. If we are looking at the particular subsurface reservoir to, store a carbon dioxide, let it be a saline reservoir, like you mentioned, or
Mm.
and any type of reservoir. What do you think is better? Being heterogeneous within a reservoir is better for better, storage, or do you think being homogeneous across the reservoir is much efficient for, storing the carbon dioxide, considering the seal is perfect?
Um. Yeah. That. Thank you, Jen, for this question. That's quite a very insightful question. I think some time back I did think about this particular question, probably when we in the MSc class.
Yeah, yeah, yeah.
Yeah, but when in geology, that you see in geology, it's hard to really get a perfect homogeneous subsurface or even surface, so to speak. So that's like an ideal case all the time. But however, there is that possibility when you look at reservoirs, like if you end up having reservoirs like how should I put it? Oh, like if you are having some kind of some kind of certain reservoirs, it is possible to have a homogeneous state. So assuming that if a subsurface is just all ultramafic or mafic compositions, that would really be perfect because we have the most calcium, in my opinion, most calcium and magnesium ions available. So whenever we pump the CO2 at that depth and we have a perfect seal, no problem of escape, there will be that time for mineralization to happen, and the CO2 can be well utilized and form stable precipitate carbonates within the subsurface. So, in my opinion, a more homogeneous depth is very, very trying to answer your question is very, very helpful, but it may also come with its own challenges. So, which I am not so sure because we might not also want like the CO2 to be a too much flow through within a reservoir. Like, there should be some impediment
Yes, yeah,
at
yeah.
some point. So that's where heterogeneous subsurface also comes in and probably maybe also have this. So I think in my case or my understanding, I think both cases are important. But if we have a particular formation that sort of favors the CO2 reacting with the favorable minerals we are looking at within the subsurface, it should be fairly more favorable. If we have more than that within the subsurface, it should be more better. Yeah.
Yeah, I see. So, the reason I was asking was, when we talk about heterogeneous, mostly we look at the carbonate rocks, right? Because their pore network is very complicated. Their diagenesis, patterns could generate some sort of, different porosity and, microporosity, things like that. And it could really complicate things for storing carbon dioxide because uh, when we inject something, we need to overcome the capillary pressure and things like that. So I was wondering which one is better. But really glad to know your opinion on this. And also, when you explain everything, it really sort of give me spotlight on the CDR thing. It is, you know, in uh, you know, easy way of saying it is really easy to do. People don't really need to be technically proficient to actually capture CO2. All they need is maybe just grow a plant around their house or something like that. This is just,
Yeah.
very basic meaning. What I'm trying to say is, even though we know that this is very easy to do, I can, in my opinion, this CDR or CCS is not really well, raised in terms of awareness to the people. So, how do you think we could kind of, raise the awareness of these very easy CDR where, almost everybody can practice, and some of the, much more complicated, technical, proficiencies to the people who are much more expertise and professional. So, put it in this way: how can we raise this awareness of capturing carbon dioxide?
Yeah. Okay. Jane, thank you very much. And maybe, to me, I think if you utilize the advertising or industry, like TV commercials and stuff, and create some sort of cartoonic scenario and simple way of explaining things, and mostly, for instance, if you are just sitting there relaxing in your couch and watching TV, and all of a sudden an advert just comes along, and it just all the time is coming almost every day, just trying to create some sort of awareness of climate change and some of explaining these technologies in a layman's like terms for people to understand, not to be technical, or even making it more a cartoon sort of way show. I think it's one way of creating that awareness to very, very a lot of public people who are not expecting some of these specific, um, um, expecting this industry, some of these specific technology streams in these industries. So I think that's, for me, that's what just comes in my mind now, making that awareness. And also now in the research sphere or in academic sphere, creating, I think, is being done though. I think that I can kind of have a very good, there's been that done, a lot of, conferences being organized relating to some of these CDR texts, and they are being sort of talks held by experts in various countries across the globe every year, or every month, talking about this to students, to professors, to, people of different, research backgrounds. Or I think it's one of, the most encouraging way of making that awareness in people within, like, should I say, the academic industry, alongside the people in the industry as well. So most of them attend these conferences, these talks, and they get new ideas, they get, new insight of particular technologies running. So that's in terms of the public, in terms of the academic sphere and the industry sphere. I think that's also one way of looking at it, and that's actually been done in recent years very well, because that's how some of us get aware of some of these technologies that's happening. So I think these are the two broad,
Yeah, yeah. So
public.
you're right. I think people will come to understand this importance of CCS or any kind of green energy related projects when we try to explain them with their daily practices, such as, for example, flooding is something that we usually experience in some kind of coastal regions and stuff. But because of this global warming and iceberg melting and stuff, sea level have been rising, and the flooding has becoming more severe year after year. So this could be the one way of educating people to do that. And yeah, thank you very much. This is just some sort of complementing to what you have just said. And the one last final question from me. This is related to not CCS, but any kind of sustainable projects in general. So since you are also the MSc graduate from sustainable engineering, other type of sustainable projects such as geothermal, let it be wind farm or let it be hydrogen, many more. And it is safe to say that nowadays, even in the current time, the CCS projects are not very common compared to the very counterpart, which is oil and gas projects. We can still see the projects of oil and gas being licensed, the issue, but CCS projects are not very licensed and issued, and not very companies are getting permissions to that. And you have very well explained about uh, what kind of challenges are kind of stopping these things. So, just your opinion, like in terms of comparing all these, sustainable green energy sources like wind farm, CCS, and stuff. Why do you think people are more into wind farm, solar energy, and hydrogen, and not talking enough about CCS?
Um. Okay, that's a very good question. Um. Like these renewable energies, as you may be aware of, like let's say solar, wind farm energy, or solar energy, or wind energy, or tidal waves, or geothermal energies. For instance, some of these renewable energies are are not are intermittent. For instance, pick solar energy. For instance, are intermittent supply of energy. So what I mean by that is it's not all the time you get the sun to be out at a particular time and place and be getting a particular energy supply all the time. So people are looking at the high demand of energy in the coming years. And as you already know, oil and gas industry play a very substantial role in terms of energy supply across the globe. And since some people are advocating to reduce the number of operations of oil and gas across the globe, or to even stop that operation at all, which I don't have a favorable opinion on that. um it's kind of on the inside trying to propel these renewable energies in that direction, which I think, yeah, it's it's kind of a, how should I put it, a, a win-win scenario cases, because when you try to increase renewable energies across the globe, as well as trying to as you are saying, is you see that more being propelled than some of these CDR texts. That's like the challenge. Even some of implementing of some of these renewable energies in itself also have some emissions coming out from them, CO2 emissions coming out from them, right?
Yeah, it is true.
So
Yeah.
it's, in other words, in my opinion, I think, yeah, I think probably because it doesn't have that energy implementation may have a more favorable outlook to the public, to public opinion, than someone trying to implement CCS or CDR technologies, because we have been before some of these CDR technologies came in, we have been aware of solar panels, solar energy, and we find them always, they are always synonymous to being
Yeah.
like a friendly sort of
Yeah, it is.
green
It is.
tech
Yeah.
tech. So
They're
people,
more
in
used to
terms of,
that.
yeah, people have gotten used to that already, and it's easy to convince people and have a positive public opinion if you want to implement such projects,
Yeah.
compared to CCS or CDR, which is, I wouldn't say fairly new, but some of these concept of CCS is still a bit new to
New
people.
and challenging to
So,
understand. Yeah.
and challenging to understand.
Yeah.
So, and I think, in my opinion, I'm not blaming experts in that area much, because sometimes it's hard to explain certain concepts to a layman if
Yeah.
it's that if you can't sort of find a very good terminologies to help, make the person understand.
Yeah.
There are people who are actually good at that, actually. So maybe that's the those kind of people we should look into, sort of advocating them to help propel this in a more friendly manner to the public. Yeah.
Yeah. So I think this is what you have just said in your presentation. I saw some slide that says about policy thing as well. I think everything is
Yeah, policy.
interconnected. So, when we look at the oil and gas wells, we have a lot of rules and regulations, right? For example, how to abandon the well, you must not flare, you must
Yeah.
approve this and that. There are so many regulations there. One of the challenges about the CCS is there is no, I mean, maybe there, but there is no enough regulation controls for these CCS project bodies to actually follow and execute the projects in a environmentally friendly or acceptable manner. So governments needs to pace up these kind of installation of these policies so that people and companies and also other interested parties can advertise more into these CCS projects, and people will become more aware to this CCS and what does it mean, how why is it so important and things like that. And I believe everything is interconnected. Okay, so from my side, this is everything that I wanted to ask, and I would like to thank you for coming over today and sharing about what you know about the CCS and sharing lots of insight into this project. Yeah,
Okay. Thank you, everyone, for taking time to listen. And like I did said, I'm just a student, like probably most of you here,
yeah,
and
yeah,
I'm just learning as well as the little I've known in the past years. I'm just trying to share, and I'm also happy to get. I'm happy to learn more. If you
yeah,
feel free to get in touch, if you want to, us to talk, discuss more on some of these issues. And with the coming seminars, I will try and zoom into particular technologies,
yeah,
and we do a more technical aspects of some of these CCS projects and some of the challenges that probably may be faced when you are trying to scale some of these CCS projects on a much more larger scale.
yeah,
So really, really appreciate your time as well, and thank you, Jane, for for hosting this
yeah,
meeting,
yeah,
and Josh, thank you for participating, and thank you very much for for um for for your time.
yeah. Thanks very much
Thank
for
you.
your
Thank you very much,
commitment. Yeah.
Tony. Appreciate
Enjoy
it.